Hi friends. So in this video we are going to learn everything about BST, which is called as binary search tree. So if you want to learn about how to insert data, how to traverse it, how to search data, and most importantly and difficult, how to delete data in a binary search tree, watch this entire video. I am going to explain the theoretical and the hands-on coding, like practical, both parts in this video. So let's begin. What is search or the binary search tree? It's a special kind of binary tree wherein you can do the search in a logarithmic way, which means like really fast. So this is my tree. It is a binary tree because it has two, like bicycle, or wherever the two binary, you have two children from of any node, you will have maximum two children. So this is how, but this is arranged in such a way, like any binary tree, if it has a constraint or if it has a rule that whatever the left element is supposed to be less than that of parent, then that kind, and whatever is the right element is greater than the parent, then that tree is called as binary search tree. And why do we have this rule? Because so that search becomes easier. If you need to search for example 40, what you would do? 40 is less than 50, yes, traverse left. Is 40 less than 30? No, it's greater, traverse right. And in just two hops you get the data. Otherwise, if you save this as an array, then you will have lot many elements to hop, like it the o big O number or complexity would be o n, because all the n numbers you would find and then you might find in between. So enough of the theory, let's start implementing it. So what first thing we'll do is we will implement the insert. Now before doing that, binary tree can be, it's a logical data structure. So the main data structure could be an array or a linked list. So usually, people implement it with the linked list way. So that's what we are going to do here. So we have a node class, and what it has is two children. First children we would call it as left, second would be right, and then each node would have some data, and data would be of type integer. So we can call it as int. And then we would have a constructor. So if someone wants to create the node, what all he needs to do is he need to pass data, and then that would get assigned to the data object. So you have data, and whatever value is assigned, that would get. My IDE is a bit, it's lagging a bit. So, but that's fine. I think it would come in senses in a bit. So let's first implement the insert. So how it happens is, for you need a root basically for all of this. So root means the beginning. Let's say here you have the 50, that is called as the root. So root node you can say like this, right? So that's the starting point of a tree, or the root, as you know, it's an inverted tree in general. It looks like some mountain. So if you will see that this the root, and then it has two branches, and then branches, further branches. So first thing we are supposed to implement is the insert. So what we are going to do is we are going to have a helper as well, because we are going to do it in a recursive way. So recursive way means we would pass the node and then the data, and this thing will happen. So our root to begin with would be empty because there is no data. So what we are going to do is we are going to do insert r. First we will pass root, and then whatever is the value we need to insert. So we will get the argument from here, right? So we would say it as data, which is d, correct? And then we have to return the same thing. So since this root would be empty, so first time this would get inserted. and then let's see. So whenever this gets called, first we will compare our first element. Let me scroll it up so you guys can find it in center. So we will have, if root is null, then return a new node with the value passed in there. So root would get called, this will be empty, it would return, so root would get inserted here. For example, if you are passing the data, which is 70, so you will have the root. So then we will do the comparison. Comparison looks like if whatever data is less than your current node's data, then you have to go to right, else you have to go to left. And what would you do with that? So if you are coming to left, you would say the current node dot left will get the basically it would again call this. Hey, sorry about the phone call. So what we are going to do is we will insert the data. Uh, so we will call it recursively, and until and unless it gets its position, it would call and dot left, and then like whatever is the data. If this data is null, then it would create the data like this and assign it here. And same thing would be done. We need to do it for right. So actually I messed it up. So if this is left, it would go here. But if it is greater, like the current data is greater, it would go to the right. And at last we would return the node, the current node. So this would take care of the insertion. I can, just show you in a debug mode real quick how it's happening. So first we are trying to call our root element, and then our root element is probably this 50, right? So what happened is that it came here, and then since the first node was null, it is assigned, it made the 50, it got assigned to root, and we exit. Now let's say if we have 20 and 30 both, how would the flow would look like? So first the root would get assigned, and then we say 30 is the data of the current node, and then this data is more like what is the value of d. Basically it's 30, right? So then it get assigned, and then it got returned, and then it got here. So if you have 20 value, so what is happening is your current data is right now 20, and the data you need to sorry, the new node is supposed to be 20, but current data is 50. So it would go left, and then it would get created, and then it would get assigned, and then it would be returned. Now we need to print. That would be easy, right? So there are three kind of traversals. First is pre-order, second is in order, and third is post-order. Pre-order means first you go left node of the tree, then right node, and then the root. So root, no, actually I told it inverse. So in the pre, it's first root comes, then left, right. In order, the left, root, right, and then in the post, left, right, and then the root, right? So the benefit of in order is we would see the values in a sorted order. So that's how it happens. So let's first try to do an in order traversal. We would say in order, and you will initiate this, and then you would call the in order recursive method with the root as argument, and then this method would do all the work for you. So let's create that method. Now what will happen here is you would have the base case as soon as we can call it as node actually. So n, so long as, so whenever it is null, you will return it, and you will not return anything, you will just terminate the flow, because otherwise it might be a unending loop, right? So as I said, first what we do is um, what we do is left node. So if this node is not null, then what we'll do is we will have the left node traversed, and after that you will the root comes. So root is the current node, so you would just say system.out.println, and just to look symmetric, you would do double arrow, and then you would print the data, and you will do system.out.print. Last thing would be your in order, and in order it's left, and then root, and then right, so we'll have the right, and we are done. So if we would run this, technically we would be able to see our entire tree in sorted order. So let's insert all these values, and then let's uncomment these two lines, sorry, the first line, and in order. So our O is capital here, and run this to see if our values got inserted properly, and then if it is getting printed out as well properly. So basically I did a mistake. This should be null. So whenever the base case, you have the null value, that time you return, and if it's not null, you would traverse first the left recursively until you reach the end last element, then you will start coming back, then you will print the root, and then write. So this is how is it. It's on sorted way, and then whatever is your root element, for example here our root is 50, it would almost print in the middle. That is how. So now third thing is we would try to search if element is there. Search is like more or less same. So we would do, we don't even need to make private. We would just do, just to be faster, just do this. And we can name it as search. And what we are going to do is we will compare the elements. So if your node is null, you will say not found and return. If your node dot data, whatever the data, and you also have to take the input from the user what data he wants to search. So if your data is less than this, then you would search iteratively. Let's call it a search recursively. Sorry, I said iteratively, actually it should be recursively. So you would pass the left and then the data. In case if this is not true, then what you would do is you would pass, or you would search in the right node. And in case, like even before doing that, what you would do is, if you let's say find the data, that comparison is actually missing, so let's do that. If your data is equal to this dot data, your current node dot data, you would print element found, and then you can return. And you can just make a smiley here. So this is how this thing would work. So what you could do is when you're exposing it to the client, you can just ask for the value, and then you can pass the node by yourself. So you would ask for the data from the client, and then you can do this, and you can pass the root and the data which was being asked. So let's try to search two items. First, what we do is we would try to search 100, which is not there, and then we would search 30. Let's see what does it print. Not found, found, or errors out. Cool, so it said not found. Now let's say 30, and it would say found, element found. Cool, right? So now it's the most difficult part, which is called as the deletion. So deletion has three cases basically. If you would look at the tree, for example, you want to delete an element which is 80, it's no big deal. You can just assign the node dot write as null, and this 80 would be gone. But in case if that's not true, then if it might have two children, then if you delete this, then these will become orphan, and the tree structure would be all messed up. So what you need to make sure that you replace this data with something else. For example, I need to remove 50. So what I would do is I would figure out the lowest data from the right side. So I would replace 50 with 60, and then get rid of this here. So technically this would look like this. If in case if I need to move remove 50, so we will go to right, and then whatever is the lowest or minimum value on the right, we would pick that up, and then we'll put here. In case if it has two nodes, if it has one node, let's say 70 has only 60 here. So what we would do is like right node is null. So technically if we have to remove 70 and it has one node, this will come here, like 60 would come here and 70 would get replaced. So the value of this would go up and replace this, something like that. So once you will look in the code, you will understand more. So we would have the same interface for the delete as well. We would just ask the person to give us the value which they want to delete, and then internally what we are going to do is uh, we will pass the root, delete, delete r. Okay. Now again the termination condition. So when we are trying to delete a node, and if node is null, which means we have already reached till the end, then we would just return the node which is null, one and the same thing. And if node is not null, then what? So we will iterate what is the condition. So if the value you want to delete is less than the nodes left, then you would say node dot left is equal to delete r, and then you would pass on the desired data and the node. So you would pass on the desired data. Else we would do the same thing but for the right node. So if data is greater than node dot right dot data, then node dot right is equal to delete recursively and dot right and then data. So there we should just put the data because int would get compared with int. So if so you will keep iterating, either you will end up in the null or you might end up where the data is neither smaller nor greater, which means it is equal. Correct. So this is our case basically, which we are most interested in. So what we are going to do is if it has one data, right, one node, so we will do if and dot left is not null, then and dot left is equal to delete recursively. No, actually you can replace it with r, you don't have to call it recursively. So basically our comparison should be null. So if one node is null, so there are three cases: if one or all nodes are null under it, and second case is if both nodes are not null. So this is complicated, this is simple. Let's say if left node is null, then we would replace the left with the right. So which means right could be null or right could be any value. If right could be any value and if left is null, just say here if this is not there and you are supposed to remove this, so this element and then whatever is the subtree under it would travel up. So you will ultimately delete this 40 and that's how it would go, or you would you would promote that element. So that's what we are doing, that if left is null, then we are assigning the right, else if right is null, then we are saying right is equal to left. So left could have some value or could not have any value at all. Now if both are null, if these both conditions are here, then what we need to do is we need to say node.data is equal to find minimum data on the road node which is on the right side. And final thing is we would say and then final thing is we would delete that node recursively, whatever the node which is actually would be at the minimum. So we will pass the data for that with the node. So we will say node dot whatever the node is on right and then whatever is the value for the data. So let's understand this case here. So I want to delete 70. So what would I do? Or let's say I want to delete 50. So what do I do is first I go to the right and then I find the minimum element 60. So I would assign the value 60 here, and then I want to get rid of the 60. So I'll get rid of the 60, and then whatever is this node, basically whatever are the children for this, they are supposed to be hooked up. So they are actually already. But let's say assume the different case. If I want to get rid of 70, then I have more elements. So technically what we are doing here is we are trying to find the minimum from the right, and then we are reassigning the tree from the right side. So node dot right is equal to, whenever the shift thing will happen, that would work. So we need to come up with this method which is called as find minimum on right. So this will return an integer, and then this would pick up our node, and then whatever is the value or the data of the node. It doesn't have data actually, it's a node. So we will say minimum value is equal to node dot data, in case if it has some data, otherwise it would get assigned the default value as 0. And then we will say if node dot left, because the minimum data would always be at the left, is not null, we would reassign the value of node to whatever the node is on left to that. So this would get assigned node dot left. So this would continue looping, and then what we would do, if node not left is not null, then we are assigning the value, and then whatever is the fresh value, we would assign the minimum to node dot data. We have to do it this here. The reason is, let's say if last value is null and then we call node dot data, we'll get null pointer exception. So this would work fine, and then we would say return whatever is the minimum data, right? So let's see if everything works fine. So now we are trying to delete 31st, and we got some exception which is at line number 55. And why is that? Okay, because what we did here is if node is null, we are returning. So if data came here, which means node is not null, but node dot left, the data on the left could be null. So we don't need this here, neither here. It's a good catch, while debugging we, get to know all this. So nothing has deleted, which is good, and we were able to find it. Now we'll try to delete this 30 element, and we got some null pointer at 76. And why is that? Yes, so we would do if node is not null. Okay, so the reason for that was basically here what we would do is we need to upgrade. Like when the left is null, we will send the whatever is the value. Like instead of doing this, we have to do return. So that if value is equal and if it has one node, this would be returned, and then whatever is the parent, it would get reassigned, not directly getting reassigned. In this case we are reshuffling or reshifting, but not in this case. So this minor change, which was the mistake, like we were assigning the values something like this. However, we want that value to be assigned as the the either the null or the right. That's why the problem was there, but now it would work fine. So we are able to remove 30. Now let's try to remove 50. So let's say if I would do and go for 50, and there you go, it worked fine. So I hope you have enjoyed this, and this is like, thanks for watching. And if you have any question, just feel free to ask me.